Tonight's presentation is on something I call corner theory. This will be an introduction. We're not going to cover everything that I could possibly say on it. I'm going to try to keep the presentation relatively short, and then we can go to Q&A. And if anybody has things to go into a lot of depth, maybe that'll be something that we'll look at for a follow-on presentation. So, very often we focus on how to corner at the racetrack, and everybody has seen one of these generic corner diagrams. I've lost track of how many I have drawn, but typically from one of these diagrams, people try to describe all the different phases of a corner, whether you're navigating the corner, passing if you have a corner passing situation. So there's a lot of burden that we put on a generic diagram. And one way to think about this is, yes, it is a very generic description. It's going to be missing on some things. And when you start to look at real world corners, how do these different corners fit into this generic model? They don't fit very well. So is there another approach that we can take? And it actually gets worse when you start to look at multiple different racetracks and look at how many of these corners are fit that generic model. Not many. But when we look at these different corners on the racetrack, we can start to see that there are some similarities. I've circled a set of corners that are all relatively fast corners. They are different from each other, but they have some things in common. Here's a set of slow corners. They have more in common besides the fact they're all turn 11 at their respective racetracks. They're all relatively slow. They're slow in different ways for different reasons, but they're slow. So we can maybe think about those as a group. Here's a set of corners that are, sort of big hairpins, small carousels, perhaps, that have some similarities. And these corners, actually, a couple of them are named the carousel. These have some commonalities as well. They're relatively big. They're 180-ish, maybe a little more. So perhaps rather than the generic corner analysis, we need to say, okay, there are types of corners, and we'll analyze each type relative to, what's unique about that type. So we can start with this collection of corners here. So 9 corners at a few different racetracks. It's actually 13 corners because some of these corners are bidirectional. Button Willow, it's very often run clockwise or counterclockwise. Thunderhill is sometimes run in the clockwise direction, so I'll go ahead and count those. They're very different from each other in certain aspects, but I want to start with what do they have in common and go from there. But once we've looked at those commonalities, we also need to look at modifiers. What's different about the corners? They may have different scales or shapes or widths and other characteristics. The surface may change. Laguna Seca has low grip asphalt. There may be concrete patches. Some of these corners have curbing. There may be irregularities in the surface as well. Elevation, crests, dips, so on, and then camber and camber changes as well. So, and the car may influence how we approach these corners as well. You need to think about the power and grip. And some of these corners are fast enough where aero starts to make a difference. Does your car have aero lift? Does it have, does it get planted by aero? If we go back to these corners again, can I come up with a name for this category? Let's look at the corner on the middle right. Does anybody recognize that corner? It's not exactly local. That is the kink at Road America. If you look at what follows the kink, this is 2,000 feet. That for just about any car on the planet, you're flat out. So, one of the sort of old tales or old guidelines for the track is the most important corner is the corner followed by the longest straightaway. And I would modify that a little bit. I think a long straightaway that follows a very fast corner, that fast corner is going to be a very important corner because there's a big difference in performance between cars and drivers in fast corners. Slow corners, things tend to, the performance range tends to narrow quite a bit. So it's the fast corners followed by a long straightaway that we care about a lot. And this corner is called the kink. So I'll call this corner type the fast kink. So as we look at this corner type, what is the most important performance metric? And we talked about it's a long straightaway, we want good exit speed, but how do we get there? Do we want to look at how late can we start our braking? Do we want to really get that super compressed braking zone? How quickly full throttle is achieved? That's another thing people think about a lot. How fast can I get that throttle down? High Vmin. Vmin is the minimum speed in the corner. And the last one is the peak lateral G-force. If I'm doing a measurement or I'm feeling it in the car, how much lateral acceleration do I have in the corner? Of these four choices, does anybody have any ideas about what would be the single most important of those four? So, high Vmin.
Why is that, Mark?
So, if you look at your ability to accelerate when you're already going fast, it's going to be somewhat diminished, right? Your 0 to 60 time is going to be a lot shorter than your 60 to 120 time. Cars just don't accelerate as well at higher speeds. We'll avoid the physics lecture, but it's very important to maintain that high Vmin. It is very common in some of these corners for people, I look at data, so data doesn't lie if you do it right. I see people 5, 10, 15, 20 miles per hour off of the potential of their car in these kind of corners. And if you're 10 miles per hour off the pace in a 90 mile per hour corner, it's going to be hard to make that up. So you want to avoid throwing away momentum. Momentum is this precious thing that you build up, and you don't want to squander it and throw it away in the braking zone and then try to recover it coming out of the corner. Peak lateral G can be deceiving. We'll talk a little bit about slow hands versus fast hands. If your hands are too fast, you get a high peak, but you could still be slow. It's quite possible to have higher lateral Gs and be 10 miles per hour slower. And full throttle, one thing to think about getting to full throttle quickly, if you overslow corners, you're guaranteed to be able to get to full throttle very quickly. So maybe that's not the best metric. How late does the braking start? You're talking about tenths of a second versus seconds. Saving a tenth of a second in the braking zone and throwing away a second going down the following straightaway, not a good trade-off. Okay, so as we look at these corners, let's talk about how do we achieve this high minimum speed. So we want balance, and we want it to be a smooth balance. We don't want things changing around quickly. As weight moves between the four different tires, the balance of traction changes, the handling of the car changes. We want to minimize these kind of changes, especially abrupt changes. So how do we get this balance? Let's look at a couple different aspects of it. Don't porpoise the car with the pedals. That's moving the weight between the nose and the back of the car. And don't jerk the car with the wheel. That'll mess up the lateral balance. So let's talk about brake technique. Here are two different brake pressure profiles, where 10 is maximum braking. The axis on the bottom there is distance down the track. So there are different types of corners. We touched on that already. And there may be different kind of brake pressure profiles depending on what kind of corner we're talking about. So if we care about balance, smooth balance, and avoiding upsetting the car, which of these two profiles are we going to want for these fast kinks? It's going to be the one with the lower peak pressure, right? The fast brake release we see with the red curve, that's going to cause the nose of the car is going to want to pop up. With the slow brake release we see with the purple curve, the nose of the car actually never gets fully compressed because we're not hard on the brake. We come off slowly, so the weight comes out slowly. In fact, I would recommend when you're learning this type of corner, get all of this braking done early, so that you can focus on smoothness. So how do we learn fast kinks? Key thing is eyes way ahead. The scale of these corners is gigantic. So you want to get your eyes way ahead. If you want to slow your hands down through these kind of corners, you need to be looking far ahead so you don't get a surprise. Oh, there's the apex. Let me turn. Same with braking and any other speed adjustments that you make. So longitudinal balance, what I like to do as someone's learning the corner is do an early speed adjustment. And I use the term speed adjustment instead of braking, because some of these corners, depending on the car, you may not touch the brakes. You may be breathing off of the throttle to drop the speed a little bit. If you're going fast, the car can slow down quite a bit just by taking away some throttle. So especially when you're learning the corner, get that done early. That allows you to get to an early, gentle throttle. Having some throttle helps avoid high-speed oversteer. If it's a 90-mile-per-hour corner and the back end starts to come out, that may be a little bit more excitement than what you're looking for. Especially you want to avoid taking the throttle away. That's why gentle is right there in the beginning. If you're early and you mash the throttle, then you're going to have to take it away. You don't want to do that. If you think you've applied a little bit too much throttle, pause the squeeze. Just hold your foot steady, but don't lift. Don't go the other way, because when you do that, the weight will tend to go pretty heavily to the nose, and the back end will get light. And at higher speeds, again, that can get too exciting. So lateral balance, how do we keep that smooth? Slow hands. Number one thing is slow hands. If you think your hands are slow, try going slower. One rule of thumb to keep in mind is fast corners require slow hands, slow corners require fast hands. So keep that in mind. And focus on high V min. as I mentioned previously, very often people are off the pace by 10 miles per hour or more. Fix that first. If you want to go back and say, I'm braking a little too early, maybe I could brake a little bit later, solve the V-min problem first, and then go back and address other things. It's very hard if you compress your braking zone. It's very hard to go back and fix high V-min. To get the most performance out of the corner, you're going to want to address the brake application, brake release, the timing of that. All of those things are going to be important to get the last few miles per hour. But if you're 10, 15 miles per hour off of the pace, don't worry about that stuff. Get that speed adjustment done early, get that throttle done early, focus on balancing the car through the corner. Okay, so here's another type of corner. I call this a rhythm section. In this case, I'm using this section between Cotton Corners and the bus stop at Button Willow. This is a section of track where for most cars, you're not on the brakes at all, but you're not full throttle. And what the sort of the naive approach to this is you just pick a speed. These corners are relatively similar. Just pick a speed and drive through at a constant speed. Is that the fast way? No. You're going to want to move the weight of the car forward and backward using the pedals. You're speeding up, slowing down, and you can actually get higher speed on the straights and higher speed in the corners if you take this approach. And I call it the rhythm section because typically you establish a sort of rhythm with your hands and feet as you go through these. And this shows up a lot of different places. It's a combination corner that there's no threshold braking. You're not flat on the throttle either. So I've got an example here. This is the S's at Button Willow going counterclockwise. And in this case, we're going all the way down to Star Mazda on the right. So it's a series of S's that are different radius. Typically in this direction, you need to be slowing down because the corners get tighter. Although towards the end, the curbing gets flat. So you don't necessarily have to be quite so slow. So here I've got data collected from two drivers, driver one, driver two. I've got a heat map of their trace through these corners. And the color represents longitudinal acceleration. So you see driver one does a little bit of the red represents acceleration, and the green represents a steady speed, and the blue represents braking. So driver one has pretty consistent green all the way through the S's. So this driver is not really changing speed very much. You look at driver two. Driver two is pretty busy with the pedals, accelerating, decelerating, accelerating. There's a lot going on in there with the pedals, and there's a bit of this is actual braking, not just throttle modulation. In the middle there, right under driver two's name. So, what does that look like in terms of speed and time? So this chart. A little bit busy. The upper part of the chart is speed versus distance. We've got driver two is in red in this case. So driver two is going faster and is speeding up and slowing down. Driver one is much more consistent with the throttle and just sort of very gradually slowing down, going through the S's. And if we look at longitudinal acceleration, we see, again, driver one in the dark blue is pretty consistent, is in actually just slightly decelerating all the way through. where you see driver 2 in the red, as the curve goes up and down, they're accelerating, decelerating as they go through. What difference does that make in terms of time through this section of the track? Turns out to be 2 seconds. So they enter the S's at roughly the same speed. They come out, same ballpark, but in between, one driver is managing the weight of the car and managing the speed, and gets through that section of track 2 seconds faster. That's a lot of time through that section of track. And it all comes down to making use of the pedals and coordinating that with turning. So here's another example. This is Thunderhill turn 3 and 4. We're passing from left to right on this diagram. This is roughly the line. I see a lot of people, the way they take this is they're kind of at a steady speed through this transition here, and they get most of the way through turn 4, and then they're like, oh, okay, now I can finally accelerate. I prefer a different approach through this section of track. And this is an acceleration zone, and I want to accelerate as hard as I can. And then there's a weight transfer zone. And depending on the car, this could be a little bit of brake, could be a lift off the throttle. And then I get back to acceleration. Now, these things work together. The harder I do that initial acceleration, the more effective my weight transfer is when I do a lift or a tap of the brake. I'm getting the weight, I'm compressing the springs on the rear. So as I come off the throttle, that weight wants to go forward. That forward weight gives me bite with the front tires. And if I time it just right, I get that bite right as I turn in. So I can turn in. The car responds better as I turn in for T4. That allows me to get to the throttle and accelerate through turn 4, because I didn't get this, wishy-washy push on turn in. I got a nice crisp turn in, and I can get back to the throttle. So playing around with the pedals allows me to corner better. In the high-speed kink, cornering better comes from not messing around with the pedals. So, if we go back to this theme of generic corner analysis, it starts to fall apart when we have these radically different types of corners. You need to look at the specifics of the corners. And I like to put them in families, because I can, figure out something that works one place, I can apply it elsewhere. Here's another example of a corner type. I call this carousel. 2 of these corners are actually named the carousel. Does anybody recognize where these corners are? Far right is, again, Road America, the carousel. In the middle, we've got turn 2 at Thunderhill. And then on the left, we've got the carousel at Steers Point. So this is diagrams kind of modeled off of turn 2 at Thunderhill. Let's talk about how we approach this corner. Let's say we've got a novice student in the car. The instructor is going to want to encourage them to brake in a straight line. And then as they turn in, get back to a neutral throttle and just kind of putt around, take this nice conservative line around, ride the rim. And as you start to eyeball the apex, think about starting to squeeze throttle a little bit. And as you have confidence that you're going to make the apex and make the exit, then squeeze a little bit more. That's not intended to represent mashing the throttle. You're squeezing more aggressively as you go through that corner. So that's the novice line. Maybe there's another line. So here we take a look at another another approach to that corner, very different looking line. There's my braking zone. It starts later. And there's a little turn of the steering wheel before I brake. My braking zone is still straight line, but it's not parallel with the edge of the track. I make my own straight line, and that where I place that straight line varies depending on, the car, weather conditions, tires, yada, yada, yada. So, but I make my own, I very consciously make my own straight line. And then rather than getting back to neutral throttle, I do trail braking. So I don't brake, start braking later, and maybe I don't slow down quite as much. And then I drag some brake into the corner. Then eventually I get back to neutral throttle. I've got my same, start to pick up a little bit of throttle and then squeeze as I go through the corner. Now, if I take a look at these two alternatives, you can see with my more aggressive line, I start braking later. What does that mean? I'm on full throttle on that previous straight for a longer period of time. So I'm gaining time before I ever even get to the corner. And then if you look at the novice line, I've got this huge amount of neutral throttle. Well, if I can't be accelerating, how about if I'm decelerating? So that's what that trail braking represents. I'm coming into the corner too fast, and I'm bleeding some speed through that corner. The arc length through that corner is like 900 feet. It's a gigantic corner. And if you spend, hundreds of feet on neutral throttle, that's a missed opportunity. And if you can't accelerate, you might as well be decelerating.
Mark, you have a question in the chat session about those two lines.
So I would be careful with the term double apex. It's a little bit like a double apex, but I'm not necessarily getting all the way down to that inside. But it looks a little bit like a double apex. Sometimes I use the term semi-double apex, where that first apex isn't really an apex. I'm just, sort of cutting off the track a little bit. Some corners I may use a full double apex. The full double apex in a fast corner like this works best if you've got a very light car with very big wings, because you make a very sharp corner right in the middle, and you're going fast enough that in a light car with wings, you can make that happen. So anyway, there may be a few different lines, and it's going to vary by car, right? That red line may represent a Miata line. I'm limited in how much I can accelerate because of the motor, so I might as well reduce the distance that I take around that corner. That purple line, that first apex is less aggressive, but I still got a little bit of that, tilt the car into the corner and make my own straight. So it's going to vary a lot. But I got a general rule of thumb for this. Drive it in fast, collect it in the middle of the corner, and then drive it out fast. And that's not just me saying that. Ross Bentley described the carousel at Road America that way. And what that looks like, it's going to vary a lot in this type of corner depending on the car and driver and conditions. So we covered 3 different types. There are other corner types. There's tight corners. These 3 are different. They're slow for different reasons. Connected tight corners. It has some similarities with the rhythm section, but typically there's some braking involved in these, and sometimes significant braking. Diminishing radius. These are tricky corners, and I've got a few examples here of tracks in California. These are all interesting types, and there may be other types that we could put together. So that's just a basic introduction that you should approach corners and think about corner types. And if you recognize this corner is similar to something I learned previously at another track, then try to reuse that knowledge. Take into consideration that corners of the same type may have specific variations. And don't just, use the generic corner theory. Try to specialize a little bit.